Well, hello there, wonderful people. This video is video number 85 and it's on distance time graphs. So the key word I've got for you is gradient. Again, that's just the steepness of the line. That's basically all you really need to understand in terms of different sorts of language in this. The method states that the gradient represents the speed, and it does. That's what the gradient is representing in these questions. It's the rate of change, right? You might have heard that term in science specifically. As well as maths, obviously. The steeper the line, the faster the object, the thing, is going. The flat sections are where the object or thing is stopped. These are things that you need to know. The negative gradients are the return part of the journey, if there is one. And the graphs tell us stories, and you may need to explain those stories to get your marks on these questions. These are quite nice questions. You're interpreting these graphs. Sometimes you might have to draw them yourself, but we're interpreting them mainly. All right? And let's have a little look at the first question. If I zoom in to that one, we will see what I have in store for you. So this graph shows the journey of Baz. Shows the journey Baz took to buy a chair. He went from his house and he bought a chair somewhere else, and then he came back home. Right? What time did he leave? So Baz, our mate Baz, he left, and you can see here, between 7 and 8 a.m. I know it's a bit fuzzy, but between 7 and 8 a.m. is 7:30, halfway between. So 7:30 a.m. I'm going to write down 7.30 a.m. You could write 07.30, and that you wouldn't have to therefore write the a.m. bit, right? This is a.m. on the bottom, that's fine. And how long did he stop for? So we're looking at this graph, or interpreting the graph. How long did he stop for? So I said that the stopped bits are the flat bits of the graph. So we're looking between here, all right, and here. That's the amount of time he spent at the house or shop where he bought his chair, right? Probably a shop, probably not a house, unless it was second-hand. So he went there he got there at 8:30, and he left there at 10. Okay, so how many hours is that between here? That's 1.5 hours. That is the interpretation of the graph. So how long did he stop for? I'm going to write it over here just in case you can't see it. 1.5 hours. All right, you might want to write 1 hour 30 minutes, but 1.5 hours is fine. We've kept the units as just one thing there. Time's a really tricky thing because it's split into minutes and hours and seconds, and yeah, there's a nice button on calculators we can use. I'll show you later on about that, but for now that does us for that question. All right, now in question 2 I've got the same thing, same graph, because there's more questions we could ask about this graph. All right, so same graph. Baz on his journey to buy his chair. How many miles did Baz travel in total? So looking at the miles on the y-axis scale here, the distance here. All right, and the distance is always going to be on the y-axis, and the time's always going to be on the x-axis in distance time graphs. You've got a distance there of 40 miles. That's where he stopped, isn't it? Okay, so if he went 40 miles there, he must have gone 40 miles back. All right, so he's gone 40 miles there, 40 miles back, and that would be 80 miles. So you just put your number 80, and then you write your miles in if you have to. In this instance, I'm going to. B asks between what times was the fastest part. All right, so where's the steepest line? That's what we're looking for. Okay, and we could always work this out by working out the gradient of the line, and I've showed you a video on that in literally the last one. So go back and watch the last video if you want to, right, to understand what I'm explaining here. But the difference in y divided by the difference in x is 40 divided by that 1 whole hour. That time difference is there. So that's 40 divided by 1, right? That means he's gone 40 miles in an hour, 40 miles an hour. That's how fast he's gone here, right? So is that line, well, that's definitely not steeper. Is that line steeper? Well, it's not, but you'll see what I'm talking about here. We're going to go 30 in 1 hour, 30 miles in 1 hour. So he's gone 30 miles an hour here on average. That's his average speed, okay? So between what times was the fastest part of the journey? It was between 7:30 and 8. I'm going to write that over here just in case you can't see because it might be obscured by the webcam. 7:30 and 8:30 a.m. All right. Now, how far was Baz from home at 11:45? Now, this one's a little bit awkward, right? So here's 11, here's 12. Where's 11:45? Well, each one of these 1 squares is worth 15 minutes. So, because halfway is 30 minutes. So that's 11:15, 11:30, 11:45. So if I went up to hit the line there, in fact, I'll just draw a little line instead. Can I get rid of that? I'm not sure if I can. Hold on. Let's just click that instead. All right, go up here, draw a straight line, hit the line there, go across, and you'll see how many miles he was from home at that particular time. He was between 5 and 10 miles away from home. So halfway between 5 and 10 is 7.5. So that would be my answer to that question there. And again, I'm not sure if you'll be able to see that because I might be obscuring it, but I'm writing the number 7.5, 7.5 miles away from home. All right, that should all make sense. I'm going to zoom out of that so you can see that I've written the answer in the right place. And then I'm going to have to get rid of it to move myself over. So that's gone. I'm moving over, getting used to this now. And then I'm going to zoom into the last question. Right, now the last question is about Kaz. And Kaz leaves school at 3:30 p.m. She lives 7 miles away from the school. She stopped 3 miles into the walk for 10 minutes to chat with a friend. She then continued on at the same speed until she got home. She walks at 6 miles an hour. What time is she home? Now this is a question you might want to do some highlighting for and just kind of get some information out of this question, the key bits, right? So she leaves at 3:30. We've got no scale on this graph here, so we're going to have to decide upon the scale ourselves, right? We need to draw a graph, right, and then we need to work out what time she gets home. Okay, so it's probably would say draw the graph and then work out or show the time that she gets home on the graph or something like that, right? So if she leaves at 3:30, let's just make let's make this first number here 3 p.m. All right, now I'm not going to write p.m. on all of them. All right, but there we can make that 3:30, 3:30. We can make that 4. All right, I'm just going to write 5, 6, 7, 8. All right, just in case it takes ages to get home. We don't know yet, do we? So there we go. We've got the scale going on there. There's 3:30. All right, we're going to mark that point there as 3:30. All right, up the side, and we'll have to label that as well. That would be the time. Oh, actually, let's not do that at all. Let's get rid of that because I wasn't even really paying attention to this. Right, this is about minutes, 10 minutes. All right, 10 minutes. So we have to go in the scale, a lot better scale than that. So let's make this 3. Let's make this 10 past 3 every 10 minutes, and then we've got a scale that will work, won't it? So rather than being a little bit messy and ambiguous, we can be really accurate. So that's our 3:30. All right, there's our 3:40, 3:50, 4. There's our 4:10, 4:20, 4:30, 4:40. I'm not sure that is going to work either because I think it's going to take longer than that to get home. So let's make that 3:30. All right, let's make that 3:40, 50, 4, 10, 20, 30, 40, 50, make that 5, and then make that 5:10. All right, so just imagine that I've written those numbers there. That was awkward, that was painful, but I think that this graph, this scale will work now. So that's our time in minutes, time, and we've got that in 10-minute chunks. Then on the side here we've got the miles. All right, so that's our miles, our distance, and let's go with each square being worth, or each 2 squares being worth 1 because that will fit in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whee! So she's 7 miles away from school. So she needs to get here. Yeah, we didn't actually need to do 8, 9, 10, did we? So Leaving at 3:30, stopped 3 miles into the walk for 10 minutes to chat with a friend. She then continued on at the same speed. She walks at 6 miles an hour. So she can walk at 6 miles every single hour. Now, if we went from 3:30 to 4:30, which would be 1, 2, 3, there, all right, she would be able to go 6 miles, all right, which is there. That's where she'd be able to get to, right, if she walked at constant speed. But remember, she stopped 3 miles in. So 3 miles, right, she can go half that, can't she? So there we go. That's going to be our point where she stops, all right? Hopefully that makes sense to you. Don't think I've explained that particularly well. If she can go 6 miles every hour, then that's 6 miles in 60 minutes. Okay? If we divide both those numbers by 6, what that means is she can go 1 mile in 10 minutes. Okay? So every 10 minutes, right, she's gone 1 mile. So another 10 minutes, another mile, another 10 minutes, another mile. I think I've explained that better now. All right? Making a hash of this question, I think. But I think we're just about scraping by. So I'm going to draw that line on there, because that's the point where she stops. All right? And then she stopped for 10 minutes, and that's easy to draw. So we just have our scale here, remembering that each 2 squares is worth 10 minutes. All right? And then she goes home. So same speed. So it's every 10 minutes she's gone a mile. So 10 minutes, another mile, another 10 minutes, another mile. All right? Until she gets home. All right? And that was 7 miles away from school. So if this is leaving school, this is home. All right? She's got home. She's there at whatever this time is. That's 10 minutes before 5, so that's 4:50. All right? So we've done that. We've got the problem answered now. So I'm going to change that to the actual pen, and I'm not going to write it there because you won't be able to see it. I'm just going to see if that will work. Maybe 4:50 p.m. All right, and there is our answer. Tricky question when you've got to draw your own one and work out something from it. But there we go. That is another example of a distance time graph, and it's why it's the third one in my set of 3 questions, because it's the hardest of them all. All right. Please don't berate me for the poor explanation in this last question here. I might get upset. It might hurt my feelings. Take care of yourselves. See you in the next one. Bye bye.